speaking from experience. So let me know in the chat real quick if you can see the screen. Actually, here, let's do this. Scale of 1 to 5. Put in the chat how excited you are, or yeah, let's do how excited you are from 1 to 5. 5 being super excited, 1 being like not really excited at all. Someone's making me be here, but I'm going to just get through it. For 5 being like, I love machine learning, and I'm super excited about machine learning. Let's see, I'm checking right now. Oh man, all 4s and 5s. That's fantastic. Keeping that motivation up. I'd love to hear that. All right, help me out one more time. Scale of 1 to 5. How familiar are you already with machine learning? 5 being like, I know all about it. I've built and deployed machine learning neural networks before. 1 being, I don't really know anything. Ah, fantastic. Bunch of 1s and a 4. So we got a good mix here, but this is really geared towards the 1s. And that's where I was not too long ago, but this is going to be exciting. So here's what's going to happen. I'm going to give you a few links. We're going to get started and it's going to be a good time. I think you'll enjoy it. Let me get to my slides. Here we go. That's one of the links you need. But thank you, everyone, and welcome to the Quick Draw Emoji, a machine learning tutorial. My name is Brian Ross. I am a student ambassador at Make School, a junior, meaning I just started last semester and everything is going just fine so far. And hello. And a little bit about the workshop, and my goal today is to help you identify examples of machine learning in your daily life. And there's 4 core concepts we're going to be going over here, but we're going to have this machine learning model we're going to be able to play with, we're going to be able to mix it up with, and it's going to be a good time, and maybe even get into a broader discussion about what machine learning is and how it could impact the world around us and how it does already. And it's going to be a good time. And after this, the goal of today is whenever you're in a conversation or you're with your parents or you're with your friends, and then someone brings up anything at all having to do with artificial intelligence or machine learning, you're going to have this information in the background, in the back of your head, and you're going to be able to speak knowledgeably about machine learning. And not a lot of people can, which means that you're going to look like a super genius and the smartest person in the room. And I'm going to teach you how to look exactly like that person, because really, there's 4 things you need to worry about here. There's data collection, data formatting, model training, and prediction making. And I'm going to go over what all 4 of those words means. But again, just remember those 4 things. If you're the note-taking type, if you write them down, you'll probably remember it forever after that. That's how it works with me if I write handwritten notes. But we have data collection, data formatting, model training, and prediction making. Let's make sure I didn't. Oh yeah. Make sure you put in the chat, let me know if I'm going too fast or too slow, and help me end on time. Don't be afraid to ask any questions. If you spot any typos, attention to detail is an important programming skill. Help your peers and have fun. I'm not going to just sit here and read the slides. I promise we're going to be interactive and get into it. It's going to be a good time. I saw a little red message in the chat. I'm going to make sure I can look at it. One of my favorite things to do during this is read the chat. Will we be able to get a recording? I don't know. That's a question for the Teen Tech. Yes, I believe we will be sending out the recording after. Fantastic. I'll let Teen Tech worry about that. If you miss it and you want me to give it to you again, I'll have my contact info at the end. You can be like, hey, you can give that machine learning workshop again. Actually, you're going to be able to go through it after this. So here's the first thing I'm going to be sending you. Nope, don't move the box. So this is our master document. And everything that we need is going to be on this. So here we go. I'm going to put it in the chat right here. Bang. And when we go look at this document, what do we see? The machine learning workshop master document. And so there's a whole bunch of links here. There's different levels of this tutorial. So there's one that fully is functional and you can mess with it. And then there's another version where it's actually like a walkthrough, like a tutorial, and you could build this thing yourself and, throw it on a resume or throw it on a GitHub, throw it on a rep, whatever you want. And we're going to be going through this document as we go through, but there's your document. And the one that I really want you to pay attention to first is going to be this link right here. We're going to be going on Replit. Let me know in the chat. Have you been on Replit before? Is this anyone's first time on Replit? Probably not, right? You probably used it a few times today. No, not your first time. Not my first time either. You've been here before. No problem. And if it is your first time, no problem at all. It's going to be very exciting. The only thing that is different now with Replit than in the past is you have to make sure that you have an account. So it's going to ask you to log in. Don't fork it. Do not fork it. Don't move. We're going to all be on the same document because I'm going to need your help on this. And once you've signed in, go ahead and hit run, and it's going to install some packages over here on the right. And you're just going to let it run, do its thing there. And what we have here is a predictor, and it's going to use machine learning to predict what emoji we are drawing. See, there's a happy face. And our current guess is a happy face. And go ahead and submit. Beautiful. And let's go ahead and draw this laughing dude. And give him a big smile. This is kind of what I look like. There we go. Setting in. And you can see, let's try and draw a rainbow. When I try and draw this rainbow over here, it thinks that it's a smiley face. And the reason is because our training data, it only has a smiley face and a happy face, a laughing face and a happy face. So to the neural network, these are the only two things that exist. So I want you to help me out real quick, and we're all going to be drawing emojis. We need to get this thing some more data. Oh, and everyone's already started. Wow, there we go. There's some rainbows. I wanted to be able to predict a rainbow. And I like drawing rainbows because they're quite simple. I'm the world's worst artist. There it is, current guess rainbow. As you can see, it doesn't take that much data in order for it to start making guesses and start making predictions. And it's kind of an exciting thing. And yeah, if you hit clear, then they're all gonna go away, including everything we've put in. If you hit delete, it'll probably delete your most recent one. And then you have to put in your happy faces all over again. So you can keep playing with that. And one more, there we go. Okay. Okay, back to the slides, back to the slides. So that's what we're going to be messing with today. And if you need a link, it's in that document. The link is in the chat. And then there's another link for the actual full walkthrough that I'll give you through. So what's happening here? So remember we talked about our 4 big things, which is data collection, data formatting, model training, and prediction making. So when we talk about machine learning, we have to start with this idea of data collection. So when we look over here at our Replit, what is the data collection part of this? If you want to go ahead and throw in the chat, what does it mean by data collection in this context? And then we'll talk about a broader context. Quick draw emoji by Jordan. Oh, my name's not Jordan. My name's Brian. I'm going to put Brian. Brian created this. The database that have any AI, the emojis. Okay, yeah, I'll take that. Yeah, the data in this instance really is what we're putting into our canvas here. These emojis that we're drawing. This is the training data. There's a happy face. And another rainbow for good measure. There we go. So that's our training data. And because remember, or the data collection, because the machine learning model, it doesn't have any concept of happiness or stars or rainbows. We have to give all of this to the machine itself so that it can compare different things to try and figure out what's going on. It's sort of like when you're a kid, you figure out what something is by figuring out what it's not. And the same sort of idea here, where we have to give it this information, every information that we want. And that can be quite a challenge, because think about if you were designing a machine learning model for driving, and you have to tell it literally everything there is to know about driving in every single situation. It can be tricky. So that's why companies, and big companies especially, are so focused on getting as much data as possible, because the more data we have, in our training data, we can see the more data we have, the more accurate our guesses are going to be. So data really is our super weapon for machine learning. If we can have the data, then we're going to be in a good spot, because after we get our data, we're going to be able to format that data. And when we look, that's what all this code is doing here. this code is formatting it. When we talk about like load training data, and then we come down to flatten the list and update training. This is all formatting that data and taking this raw input being me drawing on this canvas. See how it's just sort of, I'm not coding anything here. I'm just putting it in. But our code is able to almost sort of magically take this canvas, and then when I add this label to it, this happy face label to it, now all of a sudden it's making predictions. And that's a pretty powerful thing, because when you think about it, that thing always gets in my way. When you think about it, model training, we don't have anything to do with the model training. The computer's all doing all of the model training, but the prediction making is the most powerful part of machine learning. And we're going to look at some real life examples here and just start to think about just how powerful that concept really can be, and what that can kind of look like. And again, here's another example. When the machine learning model is trying to figure out what's going on, we give it all these different pictures. I mean, look at the carrots. Not one of these carrots look the same. Neither do the apples, neither do the dogs. In fact, some of the dogs don't even look like dogs. They look like horses or sea lions or something like that. Or look at this one all the way at the bottom, one over from the left. It's just like, it's like 3 eggs or something. Like, is a Pokemon looks like, execute. It's kind of silly, but in any case, the computer is going to be able to take that data in. Oh, and this one right next to the eggs, that's definitely a horse. I've looked at this a few times, and this one kind of looks like a dinosaur. But anyway, so the computer is taking all this information and then it's able to make predictions because of it's getting all of the sum aggregate of all this input, all this raw input, hand-drawn input in this case. All right, and this is pretty much what it is. It's a decision tree. When we're talking about, like, if you're trying to figure out if it's a penguin, well, does it have feathers? True or false? Can it fly? True or false? If it's true, it's a hawk. If it's false, it's a penguin. Now, we know that there's more things that have feathers and can fly than hawks and penguins, but if that's all that we're telling our machine learning model about, then that's all it's going to know about. And if we had more time, we could make our own decision trees and flow charts and stuff like that. So we already went through. Don't you love when you go to a presentation and then someone just starts flying through slides and just skipping them a bunch? So if you got the capture, I hope you got the capture. I always fail at captures personally. So plain discussion. So I want to show you all you fine people a few examples here. Put in the chat real quick. How many of you are into soccer? Is there anyone here who likes soccer? Because I'm going to guess, is there a quick way to get a lot of data in a database for AI? That is a fantastic question. And that is what a data engineer does. So at big companies, you've heard this term data scientist. So there's, like, you can think of it as there's 3 different levels. There's data analytics people, like data analysis people, and then there's data engineers, and then there's data scientists. A data analytics person is like the type of person who's going to take a bunch of data and then create visualizations from it and try and get some key insights with those visualizations and provide like high level analysis to executives and to decision makers and things of that nature. A data engineer does exactly what you're talking about, which is gets all of that data and builds like a pipeline and then gives that to the artificial intelligence to really gives it to the data scientists, and the data scientists come up with the complicated models and do like the research and figure out which is like the fastest algorithm theoretically, and then like the data scientists do the hardcore data scientists. The engineer builds those pipelines to make it faster. Someone puts in the chat, since the emoji thing only recognizes rainbow stars, etc., how would we teach it more emojis? Really great question. Love that question. I'm going to get right into that. In fact, it's super easy. Should I show it to you now or should I show it to you after? I'll show it to you now. So help me out in the chat. If I'm on a Mac, how do I make an emoji? Like what's the command for that again? Essentially, here's where all of our emojis are, right here on line 8 on learn emoji. So whenever we want to, we just follow our syntax. We put another comma, let it know we want another thing. We put 2 quotation marks, and then in here we put an emoji. How do you get an emoji? It's like Command Shift something. I'm going to look it up. You're all going to watch me look it up real quick. How to make emoji on Mac. Control Command Space. Okay, that's what I thought it was. Okay. Control Command Space. And here it comes. Oh, I clicked away. Control Command Space. I doubted it. Let's put, what do you want to draw? Put in the chat which emoji I should put in here. Corn? Unicorn? Oh. Cat? Okay, where's the cat or the unicorn? What about, I kind of want to do the octopus. There's a really good show called My Octopus Teacher. If you need something to watch, maybe I should do a bat and make it like super hard for people. Okay, I won't do that. I can't find the cat or the unicorn. So let's go with laughing and crying one. Okay, let's do the crying one. Let's do the crying one. That one's popular. I don't know how you're going to draw that. So now we have another thing, and yeah, that'll work just fine. And what we have to do when we add another, okay, you know what? We'll add heart eyes too, because I like that. Control Command Shift. And there we go. Maybe I should do this one so everyone has to draw little hearts. We'll do the heart eyes. Put some quotes around this bad boy. There we go. And looks good to me. Close the chat. And whenever that happens, we just have to hit stop up here. And then we just run. And then we hit refresh. You have to do it like in that order too. Stop, run, and refresh. And then it's going to refresh. And there we go. Now we can see our extra emojis down here. We have a crying face and a face that's absolutely in love. That's going to be employers when they hear about you knowing about artificial intelligence and machine learning. All right. So someone said they like soccer. I want to show you a video real quick, and then we'll get back over to that. But when we talk about our 4 steps, right? So think about with these 4 steps in mind. This data collection, data formatting, model training, and prediction making. Just keep that in the back of your head, because when we watch these next 2 videos, first we're going to watch the soccer one, then we're going to watch one with Mario. We all know, of course, who is Super Mario. But keep these 4 things in the back of your head, because we're going to talk about like what this actually is entailing. And by the way, this is the secret to knowing about all of machine learning. It's knowing those 4 steps, essentially. So here we go. I hope you like this, even if you don't like soccer. I really like soccer, but hopefully you like it. It'll be interesting regardless. I'm going to make it full screen. Let me know if you can hear it too. Nice ball out wide. And the shot. 3 technologies. Pretty cool, pretty cool. If you can't hear anything now, it's because there's no audio on this part of the video. You can see where the ball is over there on the screen at the right. And now we have predictions. And these words all make sense if you know if you have like a big background in soccer. If you don't have a background in soccer, you probably don't know what like Gengen pressing is, but not really too important for our purposes. Only a minute long, and it told us so much. What did we see there? All right, let's go over this real quick. Help me wrap my head around what I just saw. So, and yes, I'll give you the slides afterwards. There's like a whole tutorial you can walk through. You can go absolutely crazy. You can have a lot of fun with it. So what was our first thing? We need to get the data somehow, right? We need to get the data collection. So what is the data collection part of this, do you think? Data collection, when it comes to this, what would data collection be? Let's see if we have any, the broadcast. Yeah, that's what I would say too. Our data collection would be, like if we have this machine learning model and we want to go out in the real world and do some data science, do some machine learning, we have to get all of this broadcast footage. Like we just need this raw data. And then not only that, but There might even be a point at the very beginning when we're training our data. Well, we'll get to train data. So formatting, we won't talk about data formatting. Data formatting would be like getting all of this raw data. Actually, we can talk about data formatting. What would data formatting be in this context? Like, what is it that we want the data to format to, essentially? I wonder. Let's watch it again. Let's think about this while we watch it. What would be the data formatting? So we have the broadcast. Okay, we know that. And then we need it, maybe this over here. Maybe this is our data formatting. Maybe we need our data to really represent all of these people over here. Huh. Yeah, that could work. So when we have all of our footage, but now we're going to need someone to actually tag all of this. And we want to look like these people over here on the right. And so what actually has to happen is someone has to, at the very beginning stages, look at something like this and then tell the computer, just like we did with the emojis, hey, here's an arm right there. Here's a leg right there. And you can see over here, left arm is like this light blue line, and for our person over here, his left arm is this light blue line, and you can't even see his entire arm and see how his arm gets in front of his body. So it can be really tricky to try and figure something like this out. And like his legs don't look like this. But no machine learning model is going to be perfect. The only thing that you worry about is it good enough? So let's go ahead and play. So that's our data formatting. We want to be able to format it, make sure it looks like this. Here comes the shot. And then we have the actual machine learning part, but then the important part is the prediction making, right? We want to know if it can predict accurately. And so let's actually see what these predictions are. So that ball comes all the way out here, out wide, and we have change side all the way maxed out. So it's predicting that we're going to be changing the side or making the ball switch from one part of the field all the way over to the other. And then as we go, what's the defense going to do? It's a retreat block. So they're going to go back and try and defend. And here comes this person, passes it in, give and go, combination charge. And that's exactly what happened. Then the shot, it didn't get the shot, but you know, nothing's perfect. At that point, everyone knew the shot was coming in. So that's our machine. So that's what you can do in a soccer sense. So let's take a look at this again. And this one's going to be a little bit more involved. Hey, could you hear that, by the way? Because the next one does have audio. Okay, you could hear the video, like you could hear the crowd and stuff. And yeah, I think you're absolutely right, Aisha. Knowing the different players' moves, how they're moving the ball, seeing where they're on the field. Yeah, that's as far as prediction making, like that's the important part. So everyone's good. We could hear the video. If you can't hear it, let me know. Okay, so here we go. This one, by the way, if you haven't seen this video yet, who's seen Mar.io before? Who's seen the machine learning model with Mario? Will this be anyone's first time watching this video? Because if so, that will make me very happy. We've seen it. We've all seen it. First time. We got some first timers. Oh, man, that's fantastic. All right, ready for this? After you watch this, everyone who's learned about machine learning has seen Mar.io before. And it's like one of the day one sort of things that gets a lot of people into machine learning. In fact, it kind of got me into machine learning. This and chess. I know it's a little bit nerdy, nerd alert, but that's my thing. I'm into it. I don't care what you think. But anyway, so this is going to be really cool. And whenever you talk about machine learning to your other friends or to your mom or whatever, you can show them this, and it's going to be exactly the same starting point that everyone started at. So it's almost become a part of machine learning tradition in my mind. So here we go. And he's going to throw out some words there, some technical words. Don't worry about the words too much. We can go over all of them. If you have any questions while you're watching it, just go ahead and put in the chat. But remember, we have our big four, right? Our big four. So let's go ahead and watch this. Oh boy, I'm so excited. Hope you're excited. Yay. Yeah, definitely. I can feel the excitement coming through the computer right now. It's actually kind of crazy. Here we go. Full screen.
Welcome back, Sethling here. You're watching a skilled player play Super Mario World, but this player is not human. It's a computer program I wrote called Mar.io. This program started out knowing absolutely nothing about Super Mario World or Super Nintendo's. In fact, it didn't even know that pressing right on the controller would make the player go towards the end of the level. It learned all of these things through a process called neuroevolution. In this video, I want to teach you about how Mario learned to beat this level, Donut Plains 1, what his brain looks like, and how it's all based on actual biological evolution. So let's start out by actually looking at Mario's brain. Let's play it again, but this time we'll look at Mario's brain as it's making the decisions of what buttons to press. It's going to look a bit complicated at first, but don't worry, I'll help break it down for you. This structure of colored lines and blinking boxes is called a neural network. It's a simple mathematical model for how a brain works, but it can produce some very complicated behavior. With enough computational power, a neural network could come close to simulating a real human brain, but modern technology isn't there yet. On the left side, you have the inputs. This is what Mario sees. It's a simplified view of the level. The white squares stand for blocks the player can stand on, and the black squares stand for moving objects like enemies or mushrooms. On the right side, you have the outputs. These are the 8 buttons that Mario is able to press by using its neural network. In between the inputs and the outputs, all those lines and boxes, those are the neural network. Each free-floating box is called a neuron, and the lines connecting those boxes are like the axons and dendrites in a human brain. At any given time, only some of these neurons and connections are actually being used, and this is what people talk about when they say you only use 10% of your brain. The neural network you're seeing is a pretty complicated one, and it got so complicated as a result of a 24-hour evolutionary learning session. So to explain how neural networks work, let's rewind about 24 hours and look at how the whole process started. This is what Mario looked like at the beginning of his training session, all the way back in generation number 0. The program is probably even dumber than you thought at this point. Often it just stands there and doesn't even press any buttons. If Mario stands still for too long, it'll cut off the simulation and try the next neural network, so it's mostly just jumping from one simulation to the next. But occasionally, the neural network says to press the right button, and the player starts walking right. Behavior isn't complicated, but it's enough to make at least some progress in the level. Let's take a look at a sample neural network to understand just how that works. This is one of the randomly generated neural networks that appeared in the first generation of the simulation. There are some green lines and a red line, and one neuron in the middle. Here's how it works. A green line is a positive connection, and a red line is a negative connection. A green line reading from a black or white square will turn its output the same color. A red line reading from a black or white square will turn its output the opposite color. In this case, the green lines read from the platform that the player is standing on and make the neural network press the right button as long as the player is standing on it. However, when the red line reads a black square representing one of those Caped Koopas, it presses the A button and makes the player jump. This puts the player in a position where the green lines are no longer reading a white square, so the right button turns off and Mario just stands there. This is a really basic example that illustrates how a more complicated neural network might operate. The more lines and neurons you have, the more nuanced the decisions can be. So, how exactly do we get those more complicated neural networks? The answer is evolution. When Mario gets further right on the screen, its fitness goes up. In this case, fitness is a function of how far right it gets and how quickly it gets there. Only the neural networks that produce the highest fitness are selected to be bred, creating the next generation. It took 34 generations of genetic breeding and fitness evaluation before Mario was able to finish the level without dying and get a fitness score above 4,000. You can see there were several places it got stuck for a few generations, but it always evolved out of those ruts. Let's take a look at a few of those ruts. You can look at the top left corner of the screen to see what generation number each rut occurred on. This process of picking the fittest individuals from each generation, breeding them together, and adding random mutations very closely matches the actual process of biological evolution that took single-celled organisms and produced intelligent humans. That's the power of neuroevolution. And though we don't yet have enough computational resources to produce something on the level of the human brain this way, it's kind of neat to see what it can do on one of my favorite games. I didn't come up with this idea on my own. This algorithm is called NEAT, which stands for Neuroevolution of Augmenting Topologies. And it's based on a paper by Kenneth Stanley and Risto Mikulainen. It's a really great paper that describes how to use genetic algorithms to build up neural networks from bare bones without presupposing the best structure for the neurons and their connections.
You don't need to worry about that.
It also includes some really cool ideas for separating genomes into species, which a lot of genetic algorithms don't really try and do. I wrote Mario from scratch in Lua as a plugin for an emulator called BizHawk. As I close out the video, let's take a look at the fittest neural network in each generation. It's kind of cool how sometimes you can see them make modifications to each other and improve performance, but sometimes an entirely new species becomes prominent and dominates the others. If you'd like to do more reading about the concepts I talked about in this video, I provided some links in the video description. I had a lot of fun working on this project and I learned a ton. Hopefully you learned something too. That's about it. Thanks for watching.
Wow, what a good time that was. What'd you think? Did you like that? Because we're in the play and discussion part of the workshop right now. So let me see here. Let's look at the chat. Yeah, it was pretty cool, someone says. Some people are sending me messages privately. So if I'm reading messages, like I'm not making them up. I promise they exist. But yeah, someone says that was cool, amazing, fascinating, way more into machine learning now. How about that? That's the beauty of Mario. And that's a really cool example because it shows you the whole process from start to finish for machine learning and like kind of how it all can unfold. And we have that idea of a neural network. What's that mean, a neural network? Well, you know, when you think about our brain, you might have heard this term of synapses and like how the synapses kind of make your fingers move and your hands move and makes everything happen. And you can think of our synapses as different like on and off switches, like a computer, right? Like a computer has on and off switches with circuits. If you don't know much about circuitry, that's how every computer works. It's on and off switches. And you can make a computer in Minecraft. And it's saying, you know, if this node is on and this one is off, then we want Mario to jump. But if this one is on and this one is on, we want him to move right. Here's an interesting question. What is different from the way, let's look at it again. What's different from the way how the computer plays Mario
Welcome
versus
back, Sethling here.
versus how a human plays Mario? Like what's some of the big key differences? And this is always really interesting when we talk about machine learning and what parallels are with like human learning. What's the same and what's different between what the computer is doing, what a human would do when they play Mario? Who can give me like an example? And it's a really interesting question because it goes into how computers are thinking about things. And you don't have to just keep putting in the chat. I think you can unmute, right? You can talk. I would prefer it if you talk, but I'll take chat too. The computer doesn't always try to get the coins, unlike a human. Yeah, because what is the computer evaluating? It's evaluating fitness. Fitness pizza in my mouth. No, it's evaluating whether or not it's staying alive or not. Whereas a human is going to prioritize getting a high score and maybe taking out some Koopas because why not? Whereas the computer absolutely has no concept of even of coins or of enemies. It's it has one goal in mind, and that is to move right, no matter what the cost is. So, okay, people sometimes try to go in different ways and seeing everything while a computer only wants to get the end. That's exactly right. 100%, you're getting it. And it's kind of funny when you think about it, just the amount of, like, some of these parts here, I just can't help but laugh. Like when it just yeets itself off of like a really high area with absolutely no idea what's coming next, and it's just it just all works out. And also how it just keeps jumping and spinning every single time. It is discovered that jumping and spinning is like by far the best way to move from left to right. So not really maybe too applicable in real life, but kind of interesting when you think about it in context of Mario. And machine learning, I wish we had more time. It's 2:30. I have until 2:45. Maybe I can show just some of the video. I saw this the other day and I thought it was absolutely hilarious because one of my favorite things about machine learning and artificial intelligence when we start talking about chatbots is is how funny it can be, especially if you've been up on GPT-3. So I'm going to call a little bit of an audible because it just popped in my head and you're all going to share in this with me. We're not going to watch the whole video. I wish we could, but I'll just watch the end, because whenever a machine learning like tries to do something and the model isn't optimized, what does that look like? So let's go ahead and take a look at this. And what was it that I was looking for? Half as interesting. Okay. And yeah, so we use AI to write the best HAI video ever. This came out like 3 days ago, so you probably haven't seen it yet. And let's see here. I want to go to the very end. I don't think there's like any bad words or anything. I'm pretty sure we're good on that. So anyway, here we go. So in this video, he's using a half as interesting. The whole point of this video is he used an AI chatbot to come up with titles for videos. And and now at the very end, he's going to use an AI chatbot to like actually write the script for a video. So I hope you will enjoy this. And this will be the last video we watch, and then we'll do some stuff to stay in touch after this. So anyway, watch this. I think you'll like it. I like it a lot.
Cover. Get temp.
Terrible.
Okay.
Thought the place seemed nice, decided to stay a while, didn't prep for winter, all his cattle
I think
died,
I'm on the right
and then he
spot.
got mad and cursed the place as Iceland, and since he later came back and settled there permanently, the name stuck to this day. That's right, Iceland was named after an insult from a guy who hated it. That would be like naming HAI, hey Sam, we're tired of the jokes, please stop doing them. And so I guess that's why Iceland. Which brings us to our final video, for which we allowed the bot to run as long as it wanted with no interference, which produced
Why there are illegal the US terrible musical flight past how to make new islands in the US with no territory of land.
Despite our years of writing and interpreting nonsense for this show, even we weren't really sure what to do with that. So we decided maybe only an AI bot could understand an AI bot. So we handed that sentence to a different algorithm and asked it to write a paragraph, and here's the brilliant content it produced. Why there are illegal the US's musical terrible flight pass, how to make new islands in the US with no territory of land called Rory, so keep the sun strong and pink, green, and red. So I'm told, because I'm sure I didn't get all that from a song that isn't on the agenda. Weird, but weird. I'm lucky I have a twin sister. Okay, so maybe the AI needs a little more work. To be fair though, predictive text does better the more you give it, and we only gave it one sentence, and that sentence was nonsense. I guess we'll try again at 300. Maybe you know how to make an AI bot.
Anyway, I thought that was funny. Whenever you look at, especially GPT-3, whenever AI comes up with stuff, I just think it's hilarious. So, and I'll put a link to this video because it's not in the slides, and I'll give you a link to the slides. Here's the part where I'm going to like give you links to slides and give you links to do this workshop yourself, because I'm betting after today you're feeling probably pretty inspired, right? Or pretty determined or pretty motivated, because you're seeing all these other smart people making stuff, and you're like, man, I kind of want to make some stuff now too, and be a part of the action. So that's the link to that video. Let me give you the links to the slides. Let me go over our slides real quick, make sure I didn't miss anything, like some key part. Let's see here. Did we play with the model? We played with the model, I would say. There we go. Okay, play with your model, try more new emojis. Yeah, so you can always try more emojis. We talked about how to add emojis. That was pretty cool. All right, yeah, here's some pretty cool questions. Is it easy or hard to train a model to tell happy face and smiley face apart? Is that easy or hard? What do you think? Did you find that easy or hard? We'll compare it to rainbow versus starry eye. Which one of those is easier? You tell me. Yeah, it might be slightly hard. Thank you, Aisha. It is a little difficult trying to get them to tell them apart. They're pretty similar, right? Because what's really the key difference? They're both smiling. They're both yellow. They're both circular. The only difference is the eyes. These are dots and these are lines, and we have to tell the computer that. Whereas this, a little bit easier, right? Because we got a rainbow that's arcing over, moving over. You know, nothing at all in common with this guy, with this happy face. The only thing in common is like there is a yellow strip in the rainbow, whereas the entire emoji is yellow. But none of that is really important because it's not even seeing color; it's just seeing shape. So yeah, it's one of those interesting things that seems like a silly question, like an obvious question once you know the concepts of machine learning, but it's these types of questions that help us understand like what the computer is thinking, what the computer is going through. And that can be really useful as a software engineer or computer scientist or anyone who's involved in tech at all, to try and troubleshoot, to try and debug. You have to try and understand what it is the computer is thinking, not just what you think it should be thinking. Of course, I don't have to tell any of that to any of you. You're all well up to date with all this. What factors contribute to the increased accuracy of the model? And I'll give you the link to these slides, and I'll give it to you right now. And while I'm doing this, let me know in the chat if there are any questions at all you have with machine learning and artificial intelligence. A lot of times they're kind of used interchangeably. I think rainbow versus star eyes are more easier. You're absolutely right, Brianna Connors. And I think Brianna is a fine name because my name is Brian. And so we're kind of similar in that way. So that's the link to the slides. Yeah, that's the link to my slides. I don't think there's anything super confidential in here. You'll see like a bunch of like extra slides here at the end that you can kind of look at with like more information about Make School if you would like to. But anyway, so I told you first and foremost that you will be able to play with it yourself. So I'm going to show you what that looks like real quick. And where did our master document go? Here it is. The master doc. And where are we? Code DIY, code. All right. So if you want to do the same exact thing that I did with the code 100% working, you go to this quick draw emoji custom. You go to this one. It says start with a fully functional project. So that's what you do. This next one, code activation, is where it all works, but you just need to like turn on sections of code as you go on. So like there'll be a bunch of sections of code that are commented. So it'll look like, I'll show you. Like you see this custom display variables and how there's a bunch of hashtags around it or pound symbols, depending on how old you are. Like this hashtag means that it's a comment. So I can comment out, oh, so like all of this, I can highlight it. If it lets me highlight, there we go. And then I can, let me see if I get the right command for this. Maybe command shift that. No, it's command backslash. Oh, I just took a screenshot, my bad. Oh, by the way, that reminds me, I kind of want to take a picture. The people at Make School told me to take a picture of all of us hanging out. I don't know if anyone feels like turning their camera on for it, but anyway, it worked there. Put the hashtag. Anyway, there's sections of code that are turned off and then you can turn them back on. And you get to see like what each part of each code does. And then the big league one, code DIY, you get a quick draw emoji. This is like the minimum amount of starter code. And there's a whole tutorial. Is this the actual tutorial? I think it is. Make.sc, that's the right place I want to be. Pretty sure. I hope you all enjoyed that, by the way, while this is loading. I enjoyed giving it to you. I did this talk not too long ago to a school in, I think it was Panama. I'm pretty sure they picked up most of it. Okay, so that's the one where you kind of have to do some coding, but I want to send you to the actual, like we have an actual tutorial that you can walk through that explains it very easily. I'm going to try and find it. One of the, unfortunate parts of Make School is that whenever you try and Google anything about Make School, it doesn't know that you're talking about like a place called Make School. It thinks that you'll get articles like Make School Fun, Make School Easy. You won't actually get the school. And this is a form so we can get feedback on this tutorial itself. I'm going here because I think it'll lead me to the actual tutorial. Let's try it. I'm going to do it this way so that if you like forget the links, you can figure out how to find it yourself. So make school machine learning tutorial. There's so many tutorials. So, oh yeah, here it is, first one. So just put make school in quotes and then machine learning tutorial, and then it should pop up like the first one. And this is the one I'll give to you because I know you're feeling the motivated. Yeah, here we go. So this is an actual tutorial that's on Make School site, and it tells you how to do everything, even like how to use the tutorial itself. And there's exactly what we're doing, the quick draw emoji. And you can go to this, there's the Replit link, project overview. And let's see, when viewing a project, you see the following file structure. Oh, you're gonna have so much fun with this. You're gonna feel like such a genius. Here's all your to-dos you're gonna do: model training, data formatting, data collection. Remember, that sounds familiar. I think we talked about that. And then model.py is where you're making all the changes. And then from app, import app. This is how you run apps. Oh, I'm so excited for all of you. So anyway, just in case you have a hard time like in the very beginning, where all the magic is happening is you hit app, this folder, it opens up, model.py, and here we are. And let me uncomment all of that. There we go, it's back. I did that with command /, by the way, the /, the one that's under the question mark on your keyboard. And if you go to main.py, you'll know you're in the right place, because if you go to main.py, there's going to be nothing here. You'd be like, oh, this I knew it was bare bones with code, but this isn't really a lot. This is not where you're supposed to be. It's supposed to be model.py. If you go to setup.py, what's in setup.py? Okay, so this is like library stuff, basically. Just some requirements and things of that nature. So anyway, let me put this in chat. I didn't give it to you yet. I know it's coming. It's coming. So if we follow the emoji example, can we get AI to recognize any object? Well, that's the idea. I mean, like, you're going to be using the same process. You're using the same process of data collection, data formatting, model training, and then prediction making. So how might we better adapt machine learning to writing in general? Yeah, that's a really tricky question, because there's so much with language that is hard for a computer to figure out, right? Like, there's this famous photo of I think it was Barack Obama, and he was behind someone who was standing on a scale, like they were being weighed, right? And Obama was behind him, and he put his foot on the scale and like leaned on it. And this is a funny picture, and Obama's laughing, and the person he's doing it to has no idea. And this is a really funny picture because he's a president and he's not supposed to like play a prank on someone. But if you were trying to show that to a machine, to a computer, and say like, hey, do you think this picture is funny? It doesn't have any concept of humor. It doesn't have any concept of societal norms, of things you're supposed to and not supposed to do. And so much of language is depending on things of that nature. Most of my humor, probably like 60 to 70% of it, is like either sarcastic or like making a joke or something like that. So getting a computer to get nuance is a really tricky thing. How do we get AI to recognize an object that is not an emoji? Are there any programs that can help us get AI to recognize, say, numbers? Yes, that is like, once you've done the tutorial and you've watched more YouTube videos on artificial intelligence, and like down the line, you'll start like building more complicated projects, and you'll start thinking about these sorts of questions, like how do we get numbers, especially hand-drawn numbers. And I actually think someone at Make School made a program that was able to detect like handwritten numbers and handwritten letters, and able to translate documents that way. So yeah, no, it's definitely possible. It's definitely ways to do it. It's not as straightforward as this. It might be, actually. There might be something out there. I don't know. Actually, here's what we're going to do. you can follow up with me about that and we can figure something out, because I'm going to be doing the Coursera machine learning course over the break with Andrew Ang. Andrew, Andrew space NG is how you spell his name. And if you want to keep in contact, everyone, you all know what Discord is, right? Go ahead and join our Discord. And if you go through Spark or you go through Ramp or you go through this machine learning workshop, the person who created it is in this space. I'll be in this space. Go ahead and join the Discord. And then like I can help you out with it if you get stuck, or Jordan can help you out if you get stuck. And we can talk more about machine learning and all that sort of stuff. And there's a lot of people in there already, and it's a good time. And let me give you this feedback link if you have any feedback. And Make School, everything you do, it's like every class is big feedback form. Every tutorial has feedback. So there's a feedback for the forum. You can also give feedback on me. And it looks like our time here has just expired. And we're closing up in 5 minutes. But yeah, so you have the links to the slides, you have the links to the doc, you have the link to the Replit, you have the link. Is there anything else I need to give you the link for? Oh, take a picture. Thank you. I don't care if you don't have your camera on. I would like it if it was on. Let me see here. Let me stop share.
I just want to say this was awesome. You're a really great speaker. You made it really interesting.
Oh, my dog. I hope that's on the recording. I appreciate that, though. Thank you so much. All right, let me go. Actually, no one turn your camera on. It's just going to be me and like your names. If that's cool with you, I mean, if it's not, it's being recorded. So anyway, here we go. Ready? Command Shift. Oh, my dog. He's got his camera on. I love it. All right. Me, you, and all of our faceless friends. All right. 1, 2. Well, I want to wave. Oh, we got another person. All right. Turn your camera on. We're all doing it now. Let's just go for it. I'll take my hood off.